Every single day, we put a ton of trust in these invisible security guards that are protecting our favorite apps and websites. But what if I told you those guards could be tricked, not with some kind of brute force, but with, well, simple misunderstandings? Today, we're going to pull back the curtain on a really critical vulnerability in the very tools we all rely on to keep us safe online.
So, here is our game plan. We'll start by getting to know our digital security guard. Then, we'll dig into how a simple lost-in-translation moment can be exploited by attackers. After we peek inside the hacker's playbook, we'll talk about how to fix this communication breakdown and wrap up with a totally new way to think about security.
Okay, so let's set the scene. I want you to imagine your web application is like a super high-security building. And right there at the front door, you've got a security guard. Their job? To check everyone and everything that tries to get in. Now, in our digital world, this guard is your web application firewall, or WAF for short. It's your first line of defense. It has this rule book of all the known bad guys and sketchy things to look for, and its job is just to inspect all the incoming traffic and block anything that looks suspicious before it can even get close to the building, which is your application. Seems pretty straightforward, right? Well, this is where our story takes a really interesting turn. What happens when the way that Guard interprets the rules is totally different from how things actually work inside the building? This single question, this is what opens up a whole universe of vulnerabilities we need to talk about. And that brings us right to the core of the problem, what I like to call attacks lost in translation. See, this isn't about attackers being stronger or using some crazy new weapon to break down the door. No, the issue is way more subtle than that. It's a fundamental communication breakdown between our security guard and the very application it's supposed to be protecting. This slide just perfectly nails the problem. Okay, so look at the left side. An attacker sends this kind of jumbled up request. The WAF, our guard, sees it's trying to go into a public folder and then back out, which is weird, but it doesn't match anything in its rulebook of known attacks, so it lets it through. Looks safe. But the application on the right side, it normalizes this path. That just means it cleans it up to find the real destination, and what it sees is a direct request for the admin page. So, access granted. It's the exact same message, but two totally different interpretations with, disastrous results. So here's the crucial point, and the source material is really clear on this. This is not about attackers inventing some fancy new malicious code. It's all about exploiting the simple fact that the WAF, the server, and all the other pieces in the chain, they all read the exact same request and come to different conclusions about what it actually means. It's a system-wide inconsistency. So how do hackers actually weaponize these interpretation gaps? Well, let's crack open their playbook and take a look at the specific tricks they use to just waltz right past our digital security guard. And just so we're clear, this is not just some theory. A recent research project called WAFLed found over 1,207 unique ways to bypass major WAFs. And they did it not by hiding the attack itself, but by confusing the parser. That's the little component that actually reads and interprets every single request. The scale of this vulnerability is absolutely massive. Let's break down 3 of the most common tricks in the playbook. First up is protocol desynchronization. Think of this like smuggling a malicious package inside a totally legit-looking delivery. The guard checks the outside box, says, yep, looks fine, but the backend sees both boxes and ends up processing the malicious one. Then you've got path normalization, which we just saw. That's like giving the guard directions with a bunch of weird symbols they don't understand, but the person at the front desk inside knows exactly how to read them. And finally, inspection scope overflow. This is like hiding a weapon at the very bottom of a package that's so huge the guard is only allowed to inspect the top half. They give up and the threat gets right through.
And believe me, these vulnerabilities have a very real, very high price tag. One specific attack, a type of protocol desync, led to a single bug bounty payout of $221,000. This just goes to show you, these aren't just academic exercises. They have huge financial consequences for companies.
Okay, here's a really great, concrete example from one of the reports. So, an attacker creates a malicious payload. Then, they disguise it by compressing it, basically turning it into what looks like total gibberish. The WAF takes one look at this compressed file, sees nothing that matches its rulebook of threats, and just lets it pass right on through. But when it gets to the backend server, that server knows exactly how to decompress it. It opens it up, revealing the original attack, which then gets to run. It's basically the digital version of sending a threat written in a secret code that only the person on the inside can read. Okay, so we've seen the problem, we've looked at the playbook. It's a little scary, I get it. But the good news is it's totally fixable.
The solution isn't about building a bigger wall or hiring a stronger guard. It's all about better communication and making sure everyone is finally speaking the same language.
So the reports lay out a few key strategies. First, and this is a big one, normalize all requests before you inspect them so everyone is reading the same clean message. Second, you got to inspect everything. Decompress all the data, check the full payload, leave no stone unturned. And here's a crucial mindset shift. If the WAF gets confused for any reason, the default action should be to block the request, not let it through. Finally, your security team needs full visibility into encrypted traffic, and you need rules that stop attackers from changing a request's destination after it's been approved.
Really, it all boils down to this one core principle. Every single component in your security chain, from the very outer edge to the proxy to the application itself, every part has to be looking at the exact same standardized version of a request. No more lost in translation moments, just one request, one interpretation, and one final verdict.
So what does this all mean for the future of web security? Well, it really requires a fundamental shift in how we think about defending our applications.
The ultimate takeaway here is this. You can't just buy a WAF, stick it at the front door, and assume you're safe. Real security isn't about a single product. It's a process. It's an entire system where every single component must interpret the rules in the exact same way. In modern defense, consistency really is everything.
So I'm going to leave you with this one question to think about. In your own systems, or the systems you rely on every single day, is the security guard at the front door operating from the exact same rulebook as everyone inside the building? Because if all of your defenses don't speak the same language, that door might be a lot wider open than you think.